Hello everyone, today I'm going to explain about logic gates. Certainly, the most common logic gates are of six types, which is AND, OR, NOR, NOR, NOT, and NAND and XOR. So I'll be explaining each of them. So I'm Samson Akash Verma and my register number is URK21CS2052. Okay, let's begin. First of all, I'll write my name. And my register number is URK21CS2052. Okay, the first gate I'll do is AND gate. Okay, AND gate, the code of AND gate is 7408, and it has two outputs. Actually there can be more than two, but the most common one we can find is two, so we'll just to do with this. And AND gate, it functions as multiplication. So if we give both the inputs as 0 0, so the it will result in 0, which is the output. So for AND gate, if we want output as 1, then we have to give both the inputs as 1 1. Let's see this. See, 0 0, even if you give 1 0, it is nothing. Only it works when both the inputs are 1. So I'll just write the truth table for this. A, B, and Y as result. 0 0 0 0 1 0 1 0 0 1 1 1. Okay, this is the first, right? So what is AND gate? So I'll move on to next gate, which is OR. I'll just write here OR, maybe here. Second one, which is OR gate. I'll just write in capital. OR gate, actually it works as, the function is like sum, like whatever we give as input, it adds both of them. So let's see, I'm giving two outputs, and so two inputs and one output. Okay, I'll just write a truth table for OR gate. A, B, and Y, and 0 0 0. See, in AND gate the result was a product, and in OR gate it will be the sum of two inputs. So if I give 0 and 1, the sum will be 1, and 1 0, it will be 1, and even if 1 and 1, it will be 1. So I'll just run the OR gate. It will be 0 0, it's okay, 1 0, it's coming 1. Yes, it is working fine. So let's move on to the next gate, which is NOT gate. Right, third one, NOT gate. So NOT gate is type of invertible gate. Whatever we give as input, it inverts that. So let's see it. We're giving 0, like first we give the NOT gate. Okay, sorry. I just write the truth table for NOT gate. Simple. A, B. If we give 0, it will be 1, and if we give 1, it will be 0. I'll just run and show you guys. See, it is 0. If it is 0, the output is 1, and if the output is input is 1, the output will be 0. Come on, let's move on to the next gate, which is think not NOR. NOR is a combination of OR and NOT. So it is totally complement of OR gate. This is XOR. There is, okay. We have to yeah. There isn't specific gate for NOR, so we have to make by adding OR and NOT, combining OR and NOT. So what it does is just totally complement of OR gate. In OR gate, what it was doing was, if we gave two inputs, it would result in the product sum. Like for example, if we give 1 or 0, the output was 1, but in NOR gate, if you give 1 or 0, it is complement, right? So it won't give anything. It will only work if the inputs are, both the inputs are 0 and 0. If it is 1, it won't work. That's how it is. So let's try the truth table for this. To be a b y 0 0, the answer will be 1 0 1, the output will be 0 1 0, and still the output will be 0. 1 1, and still the output will be 0. It only works when the input would be 0 and 0. So let's move on to the next gate, which is NAND gate. For your information, NAND and NOR, they are called as universal gates. You can make any kind of gate from these two gates, so they are called universal gates. That's all. It's so simple. Then specific, there isn't a specific gate in this website for NAND, so you just have to combine and NOT. Just combine this. Like how NOR was complement of OR, NAND would be the complement of AND gate. In AND gate, we had product, right? Like if it is 0 and 0, the output would be 0, and if it 1 or 0, and still the output was 0. But it is in the case of NAND, it is totally the complement of AND. If it gives 0 and 0, the output would be 1, and if you give 0 and 1, in AND gate it was 0, but here it would be 1, because it completely complements AND gate. If you go 1 and 0, it will be 1. If you 1 and 1, it will be 0. That's how it works. Let's see it. I'll run and show you guys. Okay, NAND 0 and 0, it is 1. 1 and 0, it's still 1. When it is 1 1, the output would be 0. So let's move on to the last gate, which is XOR gate. It is a little bit different from these gates. What is XOR gate is? It is like exclusive gate, or how to say, like if both the conditions are true or both the conditions are false, the output would not be getting. So even only when one of the input is true, then we would get the output. See, I'll just show you guys. In the truth table, it will be a, b, and y. If both are same, then output would be 0, and if one of the input is true, then the output would be true. Again, if both the inputs are true, output would be false. That's how it works. See, 0 and 0, it is 0, but when it is 1, it is working, and 1 1, it isn't working, but 0 1, again it's working. So these are the logic gates. I hope whoever is watching this video have understood what I've explained. Thank you.